Hi guys, welcome to my channel. So today let's solve other lead code question, which is the second question of biweekly context 136. The description of the question is as follows: that we were given an n by n binary matrix and a row or column is considered to be palindromic if all the values are read same from forward or backward. You can flip any number of cells in the grid from 0 to 1 and 1 to 0, and we need to return the minimum number of cells. So let me explain you what exactly palindromic means. 1 0 0 0 0 1 is said to be palindromic because reading it from left to right or right to left is same. Also, to make any vector palindromic, we only need to follow one condition. That's we just need to skip the middle element if it's odd number of elements, and in either ways, or if it's even or odd, then we need to iterate till size by 2. Here size is 7, so 7 would by 2 would be 3. We'll iterate till 3, not considering 3, and we'll check if our first element and last element. So first element or ith element, in general I'd say ith element and n minus I plus 1th element are equal or not. If they are equal, then we do not need to perform any operation to make that palindromic. If those are not equal, to make that pair palindromic, as that's also part of vector, we need to add one to our operation. So I'll just write that logic over here to find the palindromic or palindromic count, or the count of operations to make a vector palindromic. I'll call that element vector, and size here would be le dot size. For int I equal to 0, I is less than size upon 2, I plus plus. I'll check if I'll initialize an answer variable with a 0 value. Ans will be incremented by 1 if and only if my element of I is not equal to element of size minus I minus 1. So if both of these elements are not equal, then my answer would be increased by 1. So I'll just return that answer from there. Fair enough. So for finding the row operations or the row count to make a matrix palindromic with all the rows considered, then I'll call it a row count to be 0, and I'll iterate. So I'll also keep track of number of rows and columns. So grid dot size here would be number of rows, and within each row there would be columns. So grid 0 dot size here represents the number of columns. So I'll iterate till my nth row, and for row count it's simple. I'll just row count plus, or for every row I'll check palindromic count for it. Palindromic of that element vector int of le, or here in this case would be my row, it would be grid of I. And let me go through columns now. J equal to 0, j is less than n, j plus plus. In this case, see, in our earlier case, as row is already a vector, so we already passed it, but now columns, in each column everything will be in one 1D vector. So 1 0 0 would be one column. So for that, and how many columns, sorry, for column how many values would be there is equal to number of rows, because if we consider one column, then the number of elements that are present in that column will be equal to the number of rows. So vector int call, I'll call it, and number of elements that's present over here would be m0. I'll iterate through every row till n for a particular column, and I'll call my column ith element is equals to my grid of row would be I, column would be j. Great. Got it? It's fairly simple. Now, uh, for call count, it would be now count palindromic of call, and I'll return minimum of row count and call count. Just me run this out. Okay, so there's some spelling error. I'll just correct them. So it's working fine. For reducing the time taken to run this program, I'll also add faster. So I'm just saying here that you do not need to import any libraries for inputting and outputting from C. So do not tie anything into CPP as I'm not taking input or giving output anything. So as these libraries won't be loaded while compilation, this would reduce the complexity by a bit, or reduce the time taken by a bit, not complexity exactly. So it's working fine. Thank you.